for two reasons. First, because we've been trying to do platform engineering for 30 years. Jenkins was one of the tools that people used to try platform engineering and many others, but now it became a thing, right? It became a thing simply because now we have, I believe, everything we need to create a platform, right? Instead of 57 different tools that don't work together whatsoever, we have the tools, and more importantly, we know how platforms, what is the logic, what is the architecture of a platform, right? And the logic is relatively simple and straightforward when building a platform. It doesn't matter whether we're talking about internal developer platform, or whether we're talking about platform like AWS or Azure or anything you want, the logic is always the same. And if there's anybody to tell me that that's not the case, then we can fight. That would be cool. So, the logic behind every platform in the world that makes sense using is that you have a service owner, that's a person or a team or a company that creates services that are consumed by someone, right? You have consumers, those are us. Like, I'm a consumer of AWS as a platform, right? You're a consumer of whatever. There are some Cloud Run is a service, whatever that something is. Owners manage those services, we consume those services, and in 100% of the cases, we consume services through an API, right? Not in 100% of the cases. In 100% of the cases that make any sense, we consume them through an API. And whenever we send a request to the API, and many people, when they say API, no, I'm using Terraform, for example. Right? No, Terraform is just a way how you can communicate to API of AWS or Azure or whatever you're doing, right? Ansible, they all do the same thing. They communicate to the API to do something. And then there are some controllers behind that API that are listening to events, like AWS. Oh, I want EC2 instance, cool. There is a controller that watches for event. Hey, Viktor wants this, cool. I'm going to do whatever needs to be done, right? Relatively easy, straightforward. 100% of the platforms are like that. Now, what changed today compared to how AWS did it, or Azure, or Google, or anybody else, what changed today is that today we have Kubernetes, right? If AWS was created today, it would be running on Kubernetes. That's almost certain. It wasn't created today, it was created a long time ago, so it's not, but the logic is still the same. And what makes Kubernetes awesome is because what I just described is Kubernetes. Kubernetes is an extensible API. Anybody can extend the API of Kubernetes to create any endpoint with any schema that follows certain specification, and anybody can create controllers that will do whatever needs to be done when somebody requests something, whatever that something is. And the only question that we have today is if that's how you're going to build a platform. And I'm going to talk today about internal developer platform, even though the logic is the same if you're building external or public platform. The only question that we have really is whether you are going to extend your Kubernetes with the goal to create a platform using third-party services, or you're going to build your own. And in most cases, you're most likely going to do both of those, right? You're going to install Argo CD, right? What does Argo CD do? It extends the API, creates 3 or 4 API endpoints, and it installs controller that does something whenever you submit Argo CD application. Flux, same thing. CMPG, same thing. All third parties, right? Now, all those third parties are designed to serve the needs of everybody, right? So, I don't know, CMPG, for example, Cloud Native Postgres. Anybody using it? Shame on you. Flux, okay, something that I know that at least 2 people use here. Flux has a bunch of things that you can do, and that's cool because it needs to serve the purpose of everybody that might ever use Flux, right? But when you're building internal developer platform, you're not thinking about all the options that anybody in the world might want to need. You're most likely going to build your own API that only has the things that make sense for your customers. And your customers are other developers in that organization, right? You might say, hey, if you're doing GitOps, all you need to do is, for example, specify the address of the repository where the manifests are. Does anybody care about I don't know, what is the interval of synchronization, whether it's 1 minute or 5 minutes, yes or no. If the answer is yes, you give them that option. If the answer is no, you say, fuck it. Am I allowed to say? Okay. No conozco la... ahora, el problema con... the problem with building your platform is that most of the time, this part is easy. I mean, it's not easy. It can take you days, weeks, months, years to build it, but we know how to do this, right? And there are many ways you can do it. You can use, I work with Crossplane, you can use Crow, you can use Kubevela, you can build it yourself with Go, right? We know how to do this, right? And most of the time, when you create a platform, you get a happy developer, right? Because those developers can just say, I want an application. Cool. What do I need to know about application? I need to know this and that. Cool, 5 things, nice. I push it to Git, or I do kube control apply, or I do whatever I want. Everybody's happy. Now, the problem is what happens afterwards. What happens the second day, or the third day, or the fourth day, right? Because creating, same thing like if you go to AWS, somebody who, my mother can create EC2 instance, right? It's easy. Now, the problem is that when something goes wrong with that EC2 instance, there is nothing she could do. It's kind of like, I don't know, right? And the same thing is happening with when we build our developer platforms. Even if you're not doing the platform as I'm describing and you're doing something very silly like packaging everything in a Helm chart or something like that, you're still going to have the same problem. Cool, you enable people to do something, and then you don't allow people to see what's going on. What is the status? Is this running or not running, right? And now many of you will say, cool, actually I will give them access to Kubernetes cluster. So you just install this Helm chart and you have access to the cluster and you go and check what's going on. But that's completely wrong, because if I use your Helm chart, that means that I don't understand all the details and I couldn't care about all the details of what's going there. So I don't know even what to look at, because there is no option to say, is this Helm chart working? Right? There is no option to say, is this Helm chart, is the application that I just deployed operational? And the reason why there is no such a thing is because Kubernetes is not designed like that. Kubernetes is designed to have a bunch of very, very small pieces that together make some sense, but you need to check every single one of them to know whether something is working, right? So if you do, let's say, a simple example. Let's see, where was I? Hey, I have notes here. Cool. Is this the correct tab? Yes, it is. Cool. Now, let's say, for the sake of argument, right? Developer defines an application. Now, this is completely stupid if you ask me, but I'm going to get to that, because you can say, hey, why would anybody want to know about the deployments and ingresses and services? And in most cases, this is not an application. In most cases, this is 5% of an application. An application would have virtual service, it would have storage classes, it would have 57 other things in the real world. But let's say that this is an application, right? And you say, cool, you just need to spend a bit of time and you learn about something called deployment, right? And you define an image, you define the port, you define limits, how much memory and CPU you need, and health checks, right? Relatively easy, relatively straightforward. It's not this straightforward. In real world, it's hard, but let's say that that's it, right? And now let's say that that developer, imagine that I'm not doing kube control apply, that I'm pushing it to Git, and then Flux is managing it, but the logic is still the same. I would do something like this. Infra, I want to apply, not that one. Where was it? File name, app error, right? You just say, I want an application, cool. I have an application running in a cluster, right? Everybody's happy. And now remember the important part. I defined the deployment, and I don't know much about Kubernetes, because a normal person, not just developer, doesn't know about Kubernetes. Just as I don't know about, I don't know, how Node.js internally works and what's the runtime and stuff like that. It's not my problem. That's not their problem either, right? And now here is the real problem here. You define the deployment, you deployed it to the cluster, and you say, is this deployment working? Anybody can answer?
It's not.
It's not working. Why it's not working? How would I find out that it's not working? Can I describe it? Mm-hmm. Okay, cool. Deployment. Okay, tell me, why it's not working?
Is the head check, no?
The readiness.
I don't know, what's the problem with this?
No.
It's not working, cool. We all know that it's not working. Can you tell me why it's not working?
You need to check the logs for
Of what?
the pod application of the pod.
Of the pod, but I did not deploy the pod. Put yourself in a shoe of developer. I never defined the pod. I don't know what the heck is a pod.
Yeah.
You told me define a deployment, and I defined the deployment. And you told me push it to the cluster, and I pushed it to the cluster. And I go and check, is this thing working? And he's telling me it's not working. And cool. Why is it not working? Let me take a look at it. And I'm looking at it right now, and I still don't know why it's not working. We know it's not fine because it says that somewhere it's not available. Minimum replicas is unavailable, kind of, and I still don't know why is that happening. Now, if you're an operator, now imagine if you would be using AWS and we create EC2 and we look at the EC2 and fine, and then AWS says you should come to the data center and check the hypervisor. Or maybe the cable of the server is unplugged. How about that, right? AWS wouldn't do that to you, right? Now, if you're an operator, then you're in luck, right? Because you can say, I know deployment creates a replica set, which makes 0 sense for a developer, right? But replica set is not where your application is. Replica set creates pods, but that's not what your application is. Pods create containers. And that's your application. Insane, completely insane. There are good reasons why it's like that, right? Architecturally, it makes sense, but it doesn't sense from the perspective of a user, right? So you would go there and say get pods, and you would say probably describe pod this one, and you find out, oh, this image does not exist, right? We know what the problem is, but from the perspective of a user of that platform, this is just stupid, right? And it's silly for 2 reasons. First, I don't know what's going on. Second, why did I want an application? Why cannot I deploy an application? Don't bother me with deployments that create replica sets, which creates pods, that services, ingresses, virtual services, storage classes, all that nonsense. That's completely nonsense. Doesn't make any sense. Now, the first problem we can solve with custom resource definitions, right? You can create a custom resource definition that is doing exactly that is describing an API exactly as the way you want it, right? And in this case, imagine that we want a database, let's say in AWS, right? What is a database in AWS? Anybody using AWS here? Cool. What is a database? RDS plus probably a couple of subnets, internet gateway, 75 other things that nobody understands in a world, right? Again, there is no such a thing as a database, right? There is a collection of tiny pieces that somehow together form a database. Now, what we can do is do something like this, create a custom resource definition. Now, I'm calling it SQL claim, right? I created a custom resource definition. Kubernetes says, hey, if you want a database, don't worry about all that stuff. Don't worry about subnets, VPCs, RDS, blah, blah, blah. Just tell me where you want that database in AWS. Tell me which type of database you want, Postgres, what is the version you want, what is the size, kind of medium. I don't know what is EC2 sizes, and where you want it to run it, and how many databases you want in that server, right? Now, this is very user-friendly interface that makes sense. Imagine that we spent like a few months figuring it out and talking with developers, kind of what do you care about, what you don't, and so on and so forth. Okay, now, if I take this and I apply it, file name, what did I put it? Examples, AWS, in this case, error. I apply it, and if I do infra get SQL SQL claims. I can see my database. This is now the same, just multiply the same problem as before with the deployment. Kind of, okay, there's something wrong with it, and I don't know what's wrong with it. I can describe it. SQL claim, what is the name? MyDB. And you will see some nonsensical message. It's waiting for composite resource that I don't know what it is to become ready, and I don't know which composite resource is waiting for, and so on and so forth. Completely doesn't make any sense. Now, if we change, let's say, we're going to change. Now, remember this part, right? This right now doesn't make any sense. Now, I'm going to change the definition. I'm going to modify vim config YAML. I'm going to change the version. This is intentionally the version that I know that fails. And there is one that doesn't. I just need to check the number. Which one works? 138. Okay. I can fix it. No, actually, what did I want to do? What did I want to do? Yes, I'm missing a piece. Sorry, guys. I'm going ahead of myself. I forgot what I wanted to say. Yeah, actually, why not? I'm going to change it, 138, cool. And I'm going to apply it again. No, not again. I'm going to apply kube control, apply, file name, config YAML. This is me fixing it. Imagine that I'm an operator. I fixed the problem. I'm not a developer anymore. And now if I describe that SQL claim, it will take a few moments until it picks up, unless I messed it up.
What have you changed it again? Because
I just, so that composition that I created, the controller and CRD, I intentionally had one that is not the correct one. You will see why in a second. I just upgraded it to a newer version. You'll see in a second why, if it works. If it doesn't work, then you will not see. Let me see, what did I do wrong here? 38, blah, blah, blah. That should be correct. And I applied it. No, I didn't apply it. Or I did. Yeah. Okay, there we go, right? Now the message is changed. Now if you look at it, imagine that you're using UI, web UI, whatever as a developer, right? Now this makes sense. It says provider config is missing and contact somebody to fix it for you. And this part is very important because when you're providing services to others, there will always be two types of cases. Like let's say AWS, right? There are things that only AWS can fix, like data center is down. Right? There is nothing I can do. And if they did their job right, designing their services, they will tell you that. When you go and see the status of EC2 or whatever you're using, you will get a message like this, right? And then you know that, oh, I need to contact AWS to fix it. And there is a second type of issues for the end users, and that's you made a mistake. You did something very, very stupid, and it's your own problem. Do not blame me. Do not call AWS. You should fix it yourself. Now, this is the first case where you get a message, contact service owner, this is not something you can fix yourself. They contact me, they call me, they tell me, Viktor, can you fix this for me? Now, imagine that now this is me going behind the scenes, file name, apply file name, what is it? Examples, provider config, AWS, right? I fixed it, and then you as a user, you go back. Sometimes it's not instant, it will take, Kubernetes, I think that it has reconciliation loop that is always increasing. Eventually, you will see something very, very different here. Come on. Any questions while waiting for this to happen? If I didn't make a mistake, let me see whether I made a mistake. Go for it.
I have a comment, not a question.
Oh, comment. Those are the worst.
Because I was remembering last week we had a problem, and it was because I was trying admission controller rule to block something in a namespace if it doesn't have to block any namespace at resource that didn't have the right label. And it seems
Not to allow to
not
do
allowed
something
to
if you don't have the
redeploy.
right label. Yes.
And I was just creating a pod and deployed the pod.
Yes.
And the thing is that when you deploy the pod, it has not been assigned any node, and Kubernetes will create an object that is kind of binding, not a role binding, a binding in the namespace that will in turn assign a node to the pod for the container then to be created. And I didn't know binding existed at all, and it was being blocked by the admission controller because the binding is not created by me. I don't know nothing about that. So it's the same situation we're describing.
Yeah.
I know nothing about that process. So then something is blocked and it's not running. And obviously I know to look into the
But
logs
that
of...
admission controller, when you tried to apply the pod?
The pod was applied perfectly, but the binding wasn't. So the pod wasn't created at all. It was in the etcd database, but that didn't have any node assigned to it. So the container was not running, but the pod was there.
That's
and it was
a
interesting
different
because,
type of problem.
Yeah. But it's like it's what you say of side effects that you don't expect, and you don't know nothing about.
Let me try to guess what you did. You created a deployment.
No, I created the pod directly.
You created the pod directly.
I created the pod, and the pod requires to create a binding that makes the pod be assigned to a node, and then the binding is gone. So I don't see it, usually, but as I was blocking anything that didn't have the right label in the namespace, that binding that is not controlled by me was blocked. And I knew to look into gatekeeper's logs to see what was being blocked, to then realize, oh, what is this thing that is a binding that is being blocked? And then I learned about that.
I would say in that specific case, the problem is probably that whomever created the admission controller.
Yeah, it was me, so it was my mistake.
Okay, but sorry for that. That admission controller should probably have been looking for something else.
Yes.
Because.
But this is the situation you say about not knowing. I assumed the pod was the only thing I needed, and then it had other requirements that are invisible to me. Because the case for deployment replica set pod is very well known, but I don't think many people know about bindings and assigning a pod to a node, how that works.
Exactly. And that's why probably if I would be doing that, I would probably go a bit further and create, let's say, a CRD application, call it application or whatever you were doing, my application, right? And then have admission controllers, not on the level of pods, but on the level of that CRD. So that if the specific values are not there, that CR based on that CRD is rejected. And if that CR is rejected, not some other resource down the line, but if you reject the thing that you're creating, then you would have the information immediately. Because that's why I said admission controller was wrong. You should have rejected the pod, not the thing that is happening down the line, right? If your abstraction is a pod, let's say, right? There are things that are happening after the pod is created. You should reject the pod. You should provide the information. You cannot create this pod. Fuck the bindings. Bindings are irrelevant here, right? For you as a user.
I don't want to know
now
about that.
You are the user and the person who created admission controller, so you have nobody to blame. But somebody else would. Okay. While talking, right? We fixed the problem. I fixed the problem as an operator of a developer. And now there is something else, right? And now as a developer, I get a message, selected region, other region is not available. Please check the spec parameters region value, right? Now, this region is many different things. In AWS, that means that VPC could not have been created, or subnets, or RDS, or whatever you want, right? But for you as a developer, all those things are irrelevant. I actually got the message selected region is not available, and this is very easy now for you as a developer. You see there, spec parameters region value, right? And then you can go and what is it? AWS. Was it this one that I used? Yes. I can just go here and say, this is wrong. I'm an idiot, right? And I can change it to US East 1. Is it US East 1 in AWS? Cool. I know what to fix. And all I now need to do is apply it again. Here we go. And eventually, this thing will work, right? Let's see. Let's see whether it does work. Okay, it will take a minute or two, something like that, right? And now, the important thing here is that if I show you all those things, this is actually what was created when I created that YAML. Now, so this thing converts itself into this. I got some, where is it? It's so long. Whatever this is, you don't see the whole screen here. Why didn't you complain earlier?
Better, thank you.
Better. Yeah, I got route, I got internet gateway, I got bunch of stuff. Nobody understands what this is, and nobody should understand. It's a combination of things in AWS, some things are outside of the AWS, and so on and so forth, right? But for me as a user, this is irrelevant, because I will never learn this. There is no Node.js developer that will ever learn. But if you propagate the messages correctly, and if you imagine that you're shopping in Amazon, right? And you don't get information whether it will travel by a plane, your package, or a bus, or whether somebody will be running with the package. You get only the information that you need. And this is what we're trying to do with Kubernetes. And the way how we're doing it, or we should be doing it, let me open an example, right? It's through a bunch of rules, right? Over here, basically, I have rules that are saying, hey, if this happens, let me see one example. Take a look at resource group, and if the status of resource group is false, and the reason is this one, then propagate this message back to the user, right? This is the message you saw, or a similar one. I'm not sure. This is now for Azure. This would be for... That one, exactly. The point is what we're trying to do now with Kubernetes is when you create a resource and a bunch of smaller resources floating down, creating some kind of mechanism that will propagate the information back to the top. Now, the challenge with all that is that you cannot send everything up to the top, because if I give you all the logs, all the statuses of everything that is happening, you're going to go crazy, because, again, you don't understand. So some kind of filtering with this is basically a very relatively simple regex. Whatever is the text on the left side of it, find this, some random value in it, and then is invalid, and then whatever else is afterwards, some simple regex. Monitor all the resources happening in a cluster, and then propagate it back. And then something like this, now, in the real world scenario, when people work with stuff, they don't do kube control describe. Oh no, actually now you see, so far so good. Now everything is working, you don't need to think about it, right? And in a real world scenario, this is all fetched through Backstage or whatever you're using, right? That is basically monitoring that top level resource, and that's the only thing you know. Actually, Backstage in my case does not even have access to all the sub resources created from it. But though that information, whenever it's important, is propagated back.
It's like adding an additional layer to the events, to the Kubernetes to get more information about.
Basically, it is querying the events of all the resources that belong to it, so created from the parent resource. And then whenever an event is created that matches certain pattern, that is pushed up to the main resource. And then when you're looking only at the main resource, you get all the information you need, whatever we choose that the information is.
That information in the message field, no? In the described message field. No?
Yeah, this is status conditions. This is standard Kubernetes way to provide information.
But the results that
actually
the manifest that you just showed me a minute ago, that's specifically from Crossplane. No?
Yeah, I'm using example with Crossplane, but you can in theory do it with any Kubernetes resource you want.
And which type of resource is the one that you created with the messages? What type of resource is that? No?
What type of resources I created?
Yeah. No, the one with all the messages?
Okay, that's a Crossplane composition in my case. Okay. That's because I work with Crossplane, but in theory you can do it with anything you want, right? In case of Crossplane, we developed, so Crossplane is based on functions, So Crossplane does not know how to do it. It's very similar to Jenkins, actually, right? No, in a positive way, in terms that Crossplane doesn't do much. What Crossplane will do depends on, in case of Jenkins would be plugins, in case of Crossplane would be functions, right? And then we developed a simple function that basically, we call it, status transformer. Basically you specify, hey, I want to monitor this resource group, whatever, or let's say this one or any resource. And if you find this message in the status or events, then push it back up the chain, propagate it as if it was the status of the parent resource itself. You mentioned earlier events. You cannot do that with events because events in Kubernetes are short-lived, right? So if you have Kubernetes can maintain, I think, 5 or 6 events only. So when the new event comes, the previous one is removed.
So linked it to the source, no, you mean, no? Linked it to a specific resource.
Yeah, you cannot monitor events because events are temporary. You can monitor them in real time, but if you go back and say, I want to see what happened to this thing, let's say an hour ago, right? You will not find information about it an hour ago simply because, no, I mean, sometimes you will, but very often you will not because if new events
the amount,
came...
isn't it? If you have a lot of events, the old ones will be removed.
The old ones are removed because of the limitations of etcd. But statuses are permanent. I mean, permanent until they change. So watching for statuses makes more sense than watching for events.
And with this, you can, with this approach, basically you can actually do the health checks, no?
Yeah,
You do the health checks, say, no, you know,
basically,
you understand what you mean, you know, with healthy status.
The whole idea is that I create something, whatever. It could be deployment like I did before, or in this case, SQL claim. And that's the only thing I know, right? What is happening behind the scenes is not my problem anymore, right? And that statement is valid only and exclusively if we actually provide the information at that level. If information is hidden below, then you need to know everything, right? If we wouldn't be doing something like this, the person where is it? The person who defined this would still need to know everything there is to know about all this, right? Because if the problem is somewhere there, you need to find it somehow. Make sense?
Yeah.
So if there is any issue of the security group, you basically encapsulate the error and say like pick another region because you don't know, just do work around, or if you want to say like contact your administrator because something.
Yeah, kind of. This is not something. It's our problem. Kind of. It's a problem on the system. Maybe cluster is down, for example, right? And then you would have a message. Hey, I'm so sorry, go and watch something on Netflix because this is something that we need to fix. There is nothing you can do. And it's fine, kind of. Basically, the biggest friction that I'm seeing in companies is most of the time, I do not know whether this is a problem that I caused or somebody else. If you give me the information, it's you or it's me, I'm fine, kind of. The same thing would be happening with if I created EC2, right? EC2 would tell me right away, you cannot have any region called other region. We don't have that thing, right? But if hypervisor goes down, then it will tell me there is nothing you can do, kind of like come back in an hour or something like that. Basically, this is the same principle that any other platform is using today.
This is what you define as CRD, isn't it?
In a controller, in this case.
In the controller. Can you, when you define the events, can you capture events that are not specifically related to you, but maybe interesting to you for some reason, for example?
Yeah, I could have star. For example, I could say all events go up. Or all events that have the word something. Or, I mean, it's regex, right? Basically, you're choosing what to propagate because up the chain. If going back to your example, the binding thingy, if that something is not available as a status of the pod, but if somebody made it available status of the pod, you would just describe the pod and say, oh, I know what the problem is. I know exactly what it is.
What I'm thinking is other situations where we are not working with a CRD, but we could have a CRD defined that filters events that are important to us that may seem unrelated. The thing is that we work for all the security setup of the cluster that has many things going on, and sometimes don't seem to be related to each other, but all of them are about security. And getting a full picture of the status of the security posture of the cluster is difficult sometimes because you don't know what is failing. The network policies, admission controller, there's a lot of security things going on, PSS.
You would still need to create a CRD.
Yeah, but I can
because
create
you cannot
a CRD
extend the deployment, for example.
But
right?
in my case, as I am in charge of security, I can create a CRD with a CR just for the tenants to check the status and have in the status, as you say, a fixed capture of the events that were going on that were important for them.
Yes. I would still, in that case, if you're doing that, meaning creating CRD and controller, even if it's only for statuses, I would still let that CRD create whatever you wanted to create yourself, simply because of the ownership, right? Because let's say you create a deployment, and the deployment owns replica set. The replica set owns pods. And then if you create a CR that is unrelated to that deployment, how do you know what to propagate there, right?
Yeah, but in this
case, it's easy because if you say, hey, CR creates a deployment, and then
you have
deployment is owned by, you're basically
filter more easily.
You're pushing it to the parent resource. Otherwise, it would be hard.
Yeah. I see. Makes sense.
That's the short one.
It's amazing.
Super informative, very interesting.
The view is like, for example, for developers, if you want to allow them to create databases, would you put like PG Postgres or something like that, that allows you to create databases without having all the storage class and these kind of things?
Yeah, so in this specific case, actually, this example is a database. And this is basically, this is not the exact one, it's a modification. I can never use things that are used by companies I work with, but basically this is similar to what some of the companies do. They say, you want a database? Cool, create a database. Pick a provider, and then they say, we can work only with AWS and Azure. Cool, those are two options in provider. Only Postgres or Postgres MySQL. Basically, you create what are the options. You expose those options as a schema in Kubernetes. Schema is a CRD, and that's it.
But would you use like third-party ones, like PG native?
Yeah, CMPG.
Or correct?
Yes. So
that one is more for operators more than developers. That's my question.
I mean, still. So let's say that CMPG, right? Still, CMPG probably has around 200 options, right? Should you, as an Node.js developer, deal with 200 options? And probably of those 200, there are 50 that you as operator will set, but they're always going to be the same, or they're going to be based on some logic, right? So basically, you want to expose things that matter, but still codify the things. It's not. I could not let you as a user use CMPG and say only specify the version, because there are some other things that in our organization must be set. But why would they force you? Oh, you care only about the version, but let's put 57 other things. So I think it's always good to create an abstraction that is specifically tailored for, so even with CMPG alone, I would still create a CRD. Now, the value of creating CRD for CMPG alone is much smaller than, let's say, for RDS, because then you have CR creates a single resource which creates everything else. In case of RDS, the value is bigger because there are more things to manage, but the logic is still the same.
Is there an easy way to restrict the values that you can set in this parameter?
Oh!
For example, restrict the region to use one.
That's another actually big thing and the reasons for something like this, right? So I can use, you mentioned admission controllers, right? Kyverno, Kubernetes validating admission policy, or whatever else you're using, right? Admission policies are not, am I not sharing? Admission policies are not a new thing. However, imagine that you don't have this. No, there is no this. And when you create a database, there is only this.
Wait a second, because
Yeah, that's how operations work.
The capture
On the
card
administrator.
went away. 1 second, sorry. Here it is. Okay.
By the way, is this too small? I can make. Now, imagine that this is what you're
Maybe
working
move
on.
the window to the right because I think something is going on with the resolution of the TV.
Sure. Good. Okay. So, imagine that this is the level on which you operate, right? Now, if you would create admission controllers, I guarantee that you couldn't be able to do it. And the reason why I couldn't be able to do it, let's say that, let me find. Okay, subnet, you need to put specific things for a subnet in case of databases, right? But subnets can be used for other things. So how do you distinguish that this policy should be applied on subnet only if that subnet is in the context of a database, and if the subnet is in a context of, let's say, creating EKS cluster, then rules should be different. There is no easy or no way at all how to do that logic. Or if I do a simpler example, let's say that you're creating pods, but in some cases you're creating pods through stateful sets, sometimes through deployment, sometimes pods directly, like in your case. And the rules should be different, right? Because the context is different.
Yeah.
Now, if you create an abstraction on top of all that, then like in case of this one, then I don't care about subnets. I don't need actually to restrict subnets in any form of way because I control through this controller what is being created. I can focus my policy only on this, right? And basically I'm giving you zero access to pods or to subnets or to whatever it is that you're managing. Basically, this is your abstraction, and I could have created a policy that would say, hey, allowed values are medium, large, and small. If you put something else, RDS would not be created. But if I go on a lower level, then the context starts multiplying, and there is no way that I can create policies that actually are effective.
And you can create that without any external admission controller, like it's like inside the tool. Like
The Crossplane, no, Crossplane does not have policies.
So you
No.
need to use Hiberno or
Yeah, Caverna or something like that.
Yeah.
That's by design. We don't want, because kind of we are in a Kubernetes world. It would be, from my perspective, waste of time for us to create a competitor for Caverna, kind of only within a context of Crossplane, because use whichever policies you want. Actually, I think since maybe half a year ago, something like that, Kubernetes validating admission policies now
Yeah,
GA.
there is a native.
Huh?
Native.
Yeah, it's GA. I mean, it was native for a while, but now it's GA, meaning that now it is part of your Kubernetes cluster anyway. So yeah, policies are not part of Crossplane, but the way to create abstraction and then apply policies to abstraction instead of...
way easier to restrict whatever you need to restrict.
Yes, makes everything so much easier. The same thing would be, let's say you have application, and you say, I don't know, image, port, whatever matters for application, and you create policy for that, and that will create the pods exactly like with bindings that he mentioned before, without you worrying about bindings within a specific context or what's not.
So running Crossplane with
Just to be clear, you can in theory or in practice do it outside Crossplane. I'm not saying that only Crossplane, yes.
with Hiberno or another admission controller for policies, it's a normal practice. You know.
Yeah.
And with other tools, with other tools, you usually deploy along with Crossplane, apart of Hiberno, for the normal workflows.
Second.
For example, he made a point that for validation, to validate what you are typing, that for example, taking an analogy, I am more Terraform user, so you have the input validation. Okay, so in here with Crossplane, it's a different thing. You have the policy. So I'm wondering in the standard workflow, with Crossplane, apart from tools like Hiberno, what other tools are commonly used?
Basically, Crossplane ends up creating Kubernetes resources like any other resource. So basically, whatever you're using in Kubernetes. So now I can tell you in companies that I'm in touch with, kind of everybody uses Flux or Argo CD. Everybody uses kind of, I don't remember the last time I looked at somebody's cluster that there wasn't Argo CD or Flux, or one of those. Maybe there is 1% using Rancher Fleet, and they don't know why. There is always policies. I don't remember last time I've said it. But when I say policies, I mean, so there are two types of policies. There are client-side policies and server-side policies. This is admission controller, server-side policies, right? You were mentioning before validation value type.
With policies you made the...
Yeah, but it's very different than policies in, let's say, conceptually than, let's say, Terraform, right? Because those are, I'm not talking about, and that's the big difference, right? That there are no policies specific to the tool that tool validates and what's not. Those are, in case of Kubernetes, policies are behind the API, right? So it's not helping you to type or anything like this. You can do whatever you want until it reaches the API, but then API validates whether this is valid or no, and says you can go or not. But yes, I don't remember the last time I saw a serious cluster without Cavern or VAP.
Okay.
I mean, there are other things. You ask what people always use. That there is always some kind of login mechanism, something for metrics, something for traces.
Yes.
Bunch of other things.
That's the full stack of the internal development platform. What you are.
Yeah. Now, if you're asking me what's the most common that I see for developer platforms, there is some way to create CRDs and controllers. In my case, that would be Crossplane. APIs and controllers, CRDs. There is almost always some kind of UI that would be most of the time Backstage, and there is synchronization like Argo CD or Flux. Those three are always there.
Actually I have not used Backstage at all.
Your life is so much nicer without it. Trust me. Backstage is horrible.
Precisely to once you are in the interface and you as a user want to deploy AWS resources, okay? What you have presented us, about the description of the resources, this was normally Backstage present to the end user.
Yeah. So the idea, one of the plugins for Backstage, which I was involved in, so Backstage initially was designed to you create a YAML that describes schema of something, and then you push it to Git, and then you let Backstage discover that YAML. That's stupid. That makes no sense, right? What we are doing, and when I say we, people, is Backstage that goes to Kubernetes cluster and asks Kubernetes, what are all the CRDs that you have in this cluster? Give it to me, right? And then presents it as a list, and user can select A, B, or C. And then when you select one of those, goes back to the cluster and asks Kubernetes, okay, what is the schema of this thing? Because that's the beauty of Kubernetes, it's discoverable. You don't need to hard code anything. You just go to the API, ask, what is the schema? And then Kubernetes would return something like this. I mean, actually no, Kubernetes would return kube control, get CRD, SQL claim, Kubernetes returns this, which is the schema of that, the same thing that you saw, but this is the schema of it. Backstage then presents the fields from that schema, everything that is in a spec on a screen. People pop, click a button. And in my case, other companies would do it differently. Then that button does not go to the cluster, but pushes it to Git. And then Git, Argo CD or Flux synchronizes it. But from the user perspective, that's irrelevant. I click the button and application is running, or I click the button and I get the database. Now the fact that behind the scenes, there is pushing it to Git and synchronizing it, so whole cycle, that's a separate story, right?
Bravo.
Are we ready then?
Let's go.
Thank you very much.